Hello, I'm Verna Phillips. I teach at Southern West Virginia Community College, and we're going to do the practice test for Math 121. Uh, this is on unions, intersections of sets, and set builder notation, as well as number patterns. Okay, here's number one on the practice test. It says write in set builder notation. Okay, 0, 1, 2, dot, 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 10. And in set builder notation, I'll write X, the set of elements X, such that X is an element of W. And W stands for whole numbers, which we went over in class. Whole numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, dot, 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 dot. And X is less than or equal to 10. And also, and X is greater than or equal to 0. Okay, number 2. Write out the set X such that X is an integer less than 4. In roster notation. Okay, that's number 2. In roster notation, all integers less than 4 is dot, 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 -3, -2, -1, 0, 1, 2, 3. Okay, it stops at 3. But it goes on and on and on forever the negative direction. Never has a last number. Number 3. How many subsets? How many subsets of A, B, C, D, E, F, H, I are there? Okay, that has 1, 2, 3, 4, 5, 6, 7, 8. 8 elements. So there's a rule that says a set with n elements has 2 to the n subsets. So therefore that has 8 elements, so I have 2 to the 8th subsets, and 2 to the 8th is be 64 times 4. I think it would be 256. Yep, 256. So it's 256 subsets. Okay, write in set builder notation. you have the set 0, 1, 2, 3, 4, 5, 6, 7. Okay, that's the set of whole numbers, the set of elements x, such that x is an element of the whole numbers, and x is less than or equal to 7, and x is greater than or equal to 0. Number 5. No, wait. Number 4b. Okay, you have January, February, March, April, May. Okay, the set of elements x, such that x is an element of the months, and it only goes through January through May. Okay, set U is 1, 2, 3, 4, 5, 6, 7, 8, 9. Set A is 2, 4, 6, 8. Set B is 1, 3, 4, 5, 7. C is 7, 8. Okay, find A intersect B. Where A and B meet, what elements do they both share? A is 2, 4, 6, 8. B is 1, 3, 4, 5, 7. So the intersection of A and B is 4. Okay, that's the only element they both have. B asks for B prime. Okay, U is 1, 2, 3, 4, 5, 6, 7, 8, 9. And B is 1, 3, 4, 5, 7. Okay, so if we eliminate 1, 3, 4, 5, 7, we'll have 2, 6, 8, 9 left. So B prime is 2, 6, 8, and 9. And C, A prime union B prime. Okay, U is 1, 2, 3, 4, 5, 6, 7, 8, 9. A is 2, 4, 6, 8. So A prime is everything but 2, 4, 6, 8, which is 1, 3, 5, 7, and 9. B is 1, 3, 4, 5, 7. So B prime is, take out 1, 3, 4, 5, 7. 1, 3, 4, 5, 7. That will leave you with 2, 6, 8, 9. So A prime union B prime. A prime union B prime was what? Okay, A prime is everything out of A. So take out 2, 4, 6, 8 out of U. If you eliminate 2, 4, 6, 8, that would leave you with 1, 3, 7, 9. And B prime, if you take out 1, 3, 4, 5, 7 out of U, you'll have 2, 2, 6, 8, 9. 2, 6, 8, 9. A prime union B prime, the union is 1, 2, 3, 6, 7, 8, 9. 2, 3, 6, 7, 8. Okay, well, now D, we don't do A minus B because that's something we didn't do in class. Now, on the next one, E asks for A intersect C, intersect A union B. A intersect C is what? 8. And A union B, okay, 1, 2, 3, 4, 5, 6, 7, 8. Now A intersect C, intersect A union B is 8. Okay, number 6. List all subsets of TIM. You have the set T, you have the set I, you have the set M, you have the set TI, the set TM, the set IM, and then TIM, because it's every set is a subset of itself, and then you have the empty set. Okay, remember, every set is a subset of itself, and the empty set is a subset of every set. Okay, we don't do number 7. Number 7 we don't do, and we leave out number 8. Now let's show what S prime intersect K is. What is S prime intersect K if we have the Venn diagram S and K? Okay, two circles that meet. 1, 2, 3, 4. Okay, S prime is 3, 4. Okay, you leave S out of the diagram altogether and name what regions you have left, which is 3, 4. K is 2, 3. So S prime intersect K is, this is 2, 3. 3. Okay, TUM prime. Here's T, here's I, and here's M. Okay, all of T and all of M would be 1, 2, 4, 5, 6, 7, 8. 1, 2, 4, 5, 6, 7. Okay, and everything but T or M is 3, 8. So if on a Venn diagram, you just shade in region 3 and region 8. Okay, use this region to find the cardinality for each problem. Cardinality means the number of elements in the set. Okay, you have R and E and N. Okay, this is 26. Here we have 9. Here we have 41. Here we have 4. Here we have 7. This is 13. And you have 37. This is 13. Okay, number of elements in N is what? Hold on just a second. Let me get my calculator. Okay, 4 plus 7 plus 13 plus 37. 4 plus 7 plus 13 plus 37 is 61. Okay, B. This is A. This is B. Number of elements in R intersect E union N. Okay, R and E meet at 9, 7, and you union that with set N, so it'll be 9 plus 7 plus 4 plus 13 plus 37. This right here is 13. Okay, R intersect E union N. 9 plus 7 plus 13 plus 4 plus 37 is 70. Number in E prime. Okay. Oh, 76 goes outside here. E prime is everything in the Venn diagram but eliminate E. 26 plus 4 plus 37 plus 76. 26 plus 4 plus 37 plus 6 is 73. Okay, we're not doing E minus R, so we'll skip D. And E, number of elements in U. That means the whole universe, everything together. Okay, so that's 26 plus 9 plus 7. Wait a minute, 26 plus 9 plus 41 plus 4 plus 7 plus 13 plus 37 plus 76. 213. Okay, the whole universe has 213 elements. And F, number R intersect E intersect N is 7. Okay, 11A. Tell if all sets are equal or equivalent. Does R A prime intersect B prime equal A intersect B prime? Okay, so here's A, here's B. 1, 2, 3, 4. A prime is everything in the picture but A. So it's 3, 4. B prime is everything but B, which is 1, 4. So A prime intersect B prime is 4. Okay, remember that. A prime intersect B prime is 4. That's the left-hand side. A prime intersect B prime equals 4. Now let's find the other side of the equation. A intersect B prime. Okay, A intersect B is 2, and everything but region 2 is 1, 3, 4. So this is the right hand side, and over here is the left hand side, so they are not equal. Okay, well that's part B, 11B. Okay, I left off by mistake A. Okay, it says all sets are equal or also equivalent. Okay, all sets are equal or equivalent, that is a true statement. Any equal sets are equivalent, but not all equivalent sets are equal. Number C. F equals 1, 2, 3. G is 3, 2, 3, 1. Then F, this is a symbol for proper subset. F is a proper subset of G. That is false. Okay, it's a subset, but not a proper subset. This symbol right here means proper subset. Okay, and if it's this symbol, that's a subset. This is just proper subset. It can't contain all the original elements in the set if it's a proper subset. Okay, and then part D. For any set, U prime equals the empty set. That is true. E. The number of proper subsets of a given set is 1 less than the number of subsets for the same set. That is true. The number of proper subsets for any set is 1 less than the number of subsets. Okay, and F, the number of elements in T union L equals the number of elements in T plus the number of elements in L. That is false, because you've got to subtract the intersection. Okay, here's T, here's L. You take all the elements in T and all the elements in L. If you don't subtract that intersection, you're naming that intersection twice. So this is false. Now, for all students taking my class, I hope you will work these problems out in advance. I gave them to you in class, and if you weren't there in class, for students who missed my class in Logan the other day, I sent them to you by email. So I hope you work these out ahead of time. Number 12. Use this Venn diagram to fill in the missing statement. You have M and you have C. 16, 8, 19, 20. What is the number of elements in M prime union C prime? M prime is 19 plus 20, which is 39. C prime is, okay, this is the number 20, not 26. C prime is, eliminate C, so it'd be 36. So M prime union C prime is all the elements in M prime plus all, this is in, all the elements in C prime minus the number of elements in M prime intersect C prime. Okay, M prime is 19, 20. C prime, okay, both of them will have 20. So you have to subtract the 20. So you'll have 39 plus 36 minus 20. 39 plus 36 minus 20 is 55. Okay, it's you subtract, because see, M prime is 19 and 20, C prime is 16 and 20, so both of them contain the number 20, so you have to subtract that 20. So it's 39 plus 36 minus 20, which gives you 55. Number of elements in what is 36? Okay, number of elements in C prime is 36. That's 12B, not 13. Okay, 13. Find A prime union B intersects C. A prime is everything but A. 3, 6, 7, 8. And B intersects C is 5, 6. A prime union B intersects C. Okay, A prime is 3, 6, 7, 8. B intersects C is 5, 6. So it's 3, 5, 6, 7, 8. Okay, 3, 5, 6, 7, 8. Number 14. It says fill in the blanks with is an element of, is not an element of, is a subset of, is not a subset of, or is a proper subset of, or is not a proper subset. Okay, A, an empty set, blank 2, 4. That is a subset of. I guess you could either say subset or proper subset. B, whole numbers blank rational numbers. Okay, I went over whole numbers and rational numbers with my students the other day. I'll refresh it in just a minute. But whole numbers are subsets of rational numbers. Okay, now you have natural numbers or counting numbers, which is the natural numbers are equal to 1, 2, 3, 4, ... And then whole numbers are defined to be 0, 1, 2, 3, 4, ... And you have integers are all the negative whole numbers, and they goes on and on and on in both directions. And then you have all the natural numbers are subsets of the whole numbers. All the whole numbers are subsets of the integers. And then the next group of numbers you have are called the rational numbers. Okay, and I think they read that with Q. And that's ... -4, -3, -2, -2, -1, 0, 1, 2, 3, 4, and then you have numbers like 1/2, 1/3, negative 1/2, on and on and on. It's an endless set. It goes on and on and on. And then you have irrational numbers. Okay, and that's I, which is another group of numbers off to themselves, like pi, 1.0100010001 dot dot dot. And they're non-repeating, non-terminating decimals. And the last group of numbers are called real numbers, which is all the numbers. Okay, so now C says -2 blank natural numbers. Okay, -2 is not an part of the natural numbers, because natural numbers are only the 1, 2, 3, 4 dot dot dot. So I would say is not a subset of natural numbers. And D, -6 is X, where X is a solution of the equation. Solution 2 x squared equals 36. That's true. So I will say it's one of the elements, and it will be a subset of, or proper subset. So I guess it will be either way. Now we'll talk about number 3, the next problem, number 15. Okay, there's 100 students in the library who responded to how they completed the research paper. Okay, now this problem, on some of them they use the word only. It says 18 used only periodicals. Only periodicals. That word only is very important. Only. Okay, 29 used web and books. Okay, and you have 100 students altogether. 15 use the web. Books and periodicals. Used books and periodicals. Use web and periodicals. And 60 use books. Okay, 7 did not use web, books, or periodicals. Now it says draw this in the represent this in the Venn diagram. So you have A, circle, which is periodicals. The next one is web. And then you books. Okay, now again, 18 used only periodicals. That 18 goes here. Beforehand, we had to subtract. 7 did not use any of them. 15 used the web and the web, books, and periodicals. So 15 is here. 15. 29 used the web and books. So 29 minus 15 is what? 14. Okay, 29 use web and books, so that's here, but you subtract the 15 and you get 14 that use web and books only. Okay, only. Now remember, 18 used only periodicals. We put the 18 here. 40 use books and periodicals. So 40 minus 15 is what? It's 25. $20 use web and periodicals. So 5 use web and periodicals only. So 20 minus 15 is 5. Now, and there was 100 students in the library, right? 100 altogether. So we could find out how many use only the web. So 18 plus 5 plus 25 plus 15 plus 14. We don't know how many use only the books. Oh, no, wait, 60 use books. Okay, so 60 use books. So 25 plus 15 plus 14 is 54. 60 minus 54 is 6. So 6 use books only. Now we can find out how many used only the web. 18 plus 5 plus 14 plus 15 plus 25 plus 6 is 83 plus 7 is 90. So 10 used only the web. How many used the web in their research? 10 plus 5 plus 15 plus 14 is 44. Okay, 44 used the web in their research. Part C. How many use books or periodicals? Add up all the numbers of periodical circles and all the numbers in the book circle. 18 plus 5 plus 25 plus 15 plus 6 plus 14 is 83. Books or periodicals? We'll do that again. 18 plus 5 plus 25 plus 15 plus 14 plus 6 is 83. Now number 16. Concerning 41 presidents in the United States, the following facts. We know the following facts. 8 held cabinet posts, 14 served as vice presidents, 15 served in the U.S. Senate, 2 served in cabinet posts and vice president, 4 served in cabinet posts in the U.S. Senate, 6 served in the U.S. Senate and vice president, and 1 served in all 3 positions. Okay, so we know so many of them served cabinet post, and so many served as being vice president, and U.S. Senate. Okay, 1 served at all 3 positions, right? And 6 served as U.S. Senate and vice president. So 6 minus 1 is 5. And 4 served in cabinet posts in the U.S. Senate. So 4 minus 1 is 3. 2 served in cabinet posts and vice president. So that's 1. 14 served as vice president. 14, 4. That's 7 here. 5 and 1, 6 and 1 more 7. 4, and so vice president is 7. 8 held cabinet posts. So that's 3 only. And it doesn't say how many served in 15 served in U.S. Senate. So 5 of 1 is 6 and 3 is 9. 15 minus 9 is 6. And there's 41 presidents. So how many didn't do any of them? 3 and 1's 4. 4 and 7's 11. 11 and 5 is 16. Plus 1 is 17. Plus 3 is 20. Plus 6 is 26. 41 minus 26 is 15. So how many had none of those positions? Is 15. Only U.S. Senate is 6. At least one of the positions would be 26. Exactly 2 positions. 9. Okay, now we're not going to do A minus C on number 17. Okay, you have these numbered regions. This is region A, which is region 2, region B, this is region 4, this is region 3, this is region C, and here's 5, this is 6, 7, and here's region 1. Here's 8. Okay, so part B, B prime intersect A. B prime is everything but B. Okay, so that's region 2, region 5, region 8, region 1. And A is region 5, region 6, region 3, region 2. And the intersection of those two is 5, 2, and 5. V is the Roman numeral for 5, and II is 2. VII is 8, and VII, 2 I's is 7, 3 I's is 8. Now C, A union B intersect C, B intersect C, where B and C meet, is VI and VII, and A is 2, 3, 5, 6. So A union B intersect C is 2, 3, 5, 6, and 7. And the next one is B prime intersect A. B prime is everything but B. So region 2, region 5, region 8, and region 1. And A is 5, 6, 3, 2. Okay, the intersection is 2, 5, 2, and 5. Okay, now part D. D, C intersect B union A prime. C is 5, 6, 7, 8. And B union A prime is everything outside A and B. Okay, no part of A and B is B union A prime. So that would be 1 and 8. So now the intersection of those two is just 8. V-I-Y. 3 I's. All right, we're not doing De Morgan's Law. We don't do that. Okay, I told everybody in class, anything we didn't do in class, we don't do. Number 19. A pizza chain is willing to pay $75 for each person interviewed about his likes or dislikes of pizza crust. Of the people interviewed, 220 like thin crust, 270 like thick crust, 70 like both, and 50 did not like pizza at all. What was the total cost of the survey? Okay, you have thin crust, and thick crust. Now, how many like both? 70 like both. And number thin, 220. So 220 minus 70 is 150. And thick crust, 270 minus 70 is 200. And 50 did not like pizza at all. So every one of these people was surveyed. Okay, so how many people were surveyed? 150 plus 70 plus 200 plus 50. Now, it's 470 people, but each person was paid 75 cents a piece. So the cost of the survey is $352.50. Okay, because they interviewed 470 people. Now number 20. In a survey of 130 people, the following data were collected. 106 subscribed to the newspaper, 29 subscribed to a magazine, 17 belonged to a CD club. Okay, so you have a newspaper, magazines, a CD club. Okay. Okay, 3 people did all 3. Okay, 3 subscribed to newspaper, magazines, and were members of CD club. 10 people subscribed to the newspaper and were members of a CD club. 10 members were a newspaper and a CD club, so it'll be 10 minus 3 is 7. 5 subscribed to magazines and were members of a CD club, so 5 minus 3 will be 2. 17 were members of a newspaper and magazine, so 17 minus 3 will be 14. Okay, 17 were members of a CD club. 7, 3, 10, and 2 is 12. 17 minus 12 is 5. Only a CD club. 29 subscribed to magazines. 14 and 3, 17, 2 is 19. 29 minus 9, 14 and 3 is 17, 2 is 19. 29 minus 19 will be 10. And 100 subscribed to a newspaper. So 114 plus 3 is 117. 117 and 7 is 124. Okay, this is a newspaper. This is 14. Okay, 14 plus 3 plus 7 is 24. Okay, and 106 minus 24 is 82. Okay, so this number here is 14. Now, 130 people were surveyed. 82 plus 14 plus 10 plus 2 plus 3 plus 7 plus 5 is 123. 130 minus 123 is 7. They didn't subscribe to any of them. Okay, so there's your Venn diagram. Now we did the test. Now let's go over these other questions. Number 1. Does 2 implies A union B, 2 is an element of A union B, implies if 2 is not an element of A, then 2 is an element of B. So if 2 is in A union B, that if 2 is not in A, then 2 has to be in B. This is true. Number 2. Is the following true or false? 2, 3 is a subset of A, implies that 2 is an element of A, and 3 is an element of A. If 2, so yes, that is true. True. 2, 3 is a subset of A. 2 and 3 both have to be elements of A. Number 3. Is this true or false? 2 is an element of A. 3 is an element of A. So that means 2, 3 is a subset of A. That is true. Number 4. Write 2, 4, 6, 8, 10 as a verbal description. Okay, I had to change these answers. I have the set of A as a set of integers from 0 to 11. I told everybody to make that the set of even integers. Even integers between 0 and 11. Okay, so that means it does not include 0 and 11. This B here should not be here. So now the other choices I'm not going to forth writing down. Number 5. -3, -1, 3, 3. Okay, and I meant for that to go both directions. And A is supposed to be the set of odd integers. Okay, I just have integers, but it's supposed to be odd integers. Okay, now fill in this blank with is an element of, is not an element of, is a subset of, is not a subset of, is equal to, not equal to, where Z is a set of all positive integers. So 2 blank set 2, 4, 6. Okay, and so that means is an element of. Number 7. A is XY, B is XYZ, is A subset of B? Yes, because XY is part of B. So therefore A is a set, B is a set, so A is a subset of B. Number 8. A is XY. B is XYZ. Find A union B. All of A and all of B put together into one set is XYZ. Okay, on number 9, A is XY, B is XYZ. Okay, find A intersect B. That symbol I have on my paper doesn't really look like an intersection sign, but that's the closest I could get to intersect on the computer. And my choices are empty set X and XYZ, all of the above. I should have had B as XY. A intersect B is XY. Number 10 is 2y $ less than equivalent to P # 4 greater than sign. Okay, both of them have 4 elements apiece, so yes, it is equivalent to. Number 11. Okay, U is 3, 5, 7, 9, 11, 13, 15. Set A is 3, 5, 7, 9. B is 7, 9, 11, 13. And C is 3, 11, 15. Find A intersect B intersect C prime. C prime, you take all the elements of C out of U, and if you eliminate 3, 11, 15 from U, where U is 3, 5, 7, 9, 11, 13, 15, take out 3, 11, and 3, 11, 15. C prime is 5, 7, 9, 13. And B is 7, 9, 11, 13. So B intersect C prime is 7, 9. And A is 3, 5, 7, 9. So the intersection of those sets is just 7, 9. Now it asks you to find the next part, the number of elements in the set A intersect B prime. Okay, B prime, you can take all the elements of B out of U, and U is what? U is 3, 5, 7, 9, 11, 13, 15. So if you eliminate 7, 9, 11, 13, you have B prime as 3, 5, and 15. And A is 3, 5, 7, 9. So A intersect B prime, the intersection of those two sets is 3, 5. And this notation, N of A intersect B, they're asking for how many elements is that? That's 2 elements, so the number of elements in that set, A intersect B prime is 2. Okay, the next problem is number 12. Does A intersect B intersect C prime equal A intersect B union A intersect C prime? Okay, this symbol right here is intersect. Number 12. Okay, so here's A, B, and C. Okay, B intersects C prime. C prime, hold on a second. B intersects C prime. Okay, C prime is 1, 2, 3, 8. And B is 2, 3, 5, 6. B intersects C prime. The intersection is 2, 2, 3. And A is 1, 2, 5, 1, 2, 4, 5. So A intersect B prime, A intersects C prime is just 2. So the left-hand side is A intersect B intersect C prime is 2. And find the other side, A intersect B union A intersect C prime. A intersect B is 2, 5. And C prime is 1, 2, 3, 8. A is 1, 2, 4, 5. Okay, so A intersects C prime is 1, 2. So A intersect B union A intersect C prime is 1, 2, 5. Does that equal this side? No. So these two sides are not equal. Okay, now a survey of 155 residents of Lake Placid was asked to what kind of water activities they participated in on a daily basis in the summer months. The following information was obtained. Okay, so many swam, so many sailed, so many water skied. Okay, so you have to draw a Venn diagram and find out how many people did none of the activities, swimming and sailing only, but only water skiing. Okay, so you have, okay, here's one circle for swim, how many swam, how many sailed, how many water skied. Okay, 35 swam, sailed, and water skied. So 35 goes here. 52 water skied and sailed. So 52 minus 35 is what? 17. Okay, water skied and sailed, B17 is here. Swam and water skied. 54 minus 35 is 19. Swam and water skied is 19. 56 swam and sailed, so 56 minus 35, 21. Okay, water skied, 19 plus 35 plus 17 is 71. 76 minus 71 is 5, so 5 water skied only. 90 sailed, so you have 21 plus 35 plus 17 is 73. 90 minus 73 is 17. And 21 plus 35 plus 19 is 85. 107 minus 85 is 22. And 155 residents. So if you add all those up, you get 22 plus 21 plus 17 plus 17 plus 35 plus 19 plus 5 is 136. 155 minus 136 is 19. Okay, so how many did none? None of the activities is 19. Swimming and sailing only, 21. Only water skiing is 5. Okay, I'm not going to do the pizza problem because I did that on the other one, the same exact problem. Okay, now number 15. Okay, what are the ways to list elements of sets? I've got protractor, ruler, compass, roster method, verbal description, set builder notation, commutative, associative, and distributive, or none of these. The answer is roster, verbal description, and set builder notation. Okay, the roster method, verbal description, and set builder notation. Define a well-defined set. As a set whose elements are clear to everybody. The empty set, a set has common characteristics, or none of these. Is a set whose elements are clear to everyone. Number 17. Is the set of nice people well-defined? No. Not set of nice people is not well-defined. Okay, because it has the word nice. Now, if I just said set of people, would be well-defined. Set of nice people is not well-defined. And here's 18. U is A, B, C, D, E, F, G, H, L, J, K. Okay, A is A, C, E, F. B is B, C, F, G. C is C, D, F, G. Okay, find A prime. Okay, take A, C, E, F out of U. U is A, B, C, D, E, F, G, H, L, J, K. A prime, you got to eliminate ACF, ACEF, and so that will leave you with B, D, G, H, L, J, K. And then B prime is what? B is B, C, F, G, and U is A, B, C, D, E, E, F, G, H, L, J, K. So if you take out B, C, F, G, B prime is A, D, this is E. Okay, A, D, E, H, L, J, K. And A is A, D, E, H, L, J, K is B prime. So you have B prime is A, D, E, H, L, J, K. And A is A, C, E, F. A union B prime is A, C, D, E, F, H, L, J, K. Okay, what's number 19? A finite set. Finite set is a set with elements whose elements can be counted. Finite set is a set of elements whose can be counted. Finite set. Set whose elements can be counted. Okay, number 21. Okay, A is 1, 3, 5, 7, 9. B is 3, 7, 7, 9, 3, 10. Is A equivalent to B? No, it is not, because A has 5 elements and B has 4. To be equivalent, they have to have the same number of elements. So no, it is not equivalent. Okay, number 21. A equals 1, 5, 9, 13, 17, ... That's what kind of sequence? Okay, to get one number to the next, you're adding 4. If you add the same number to every term, it's called an arithmetic sequence. A is 9, 8, 17, 25, 42 is what kind of sequence? Okay, to get one term to the next, you're adding the previous 2 terms. If you add the previous 2 terms together, it's called a Fibonacci sequence. Now Now 23. What is a symbol for an empty set? Okay, one of the choices is this, or a circle with a line through it, which is that. Okay, that is the symbol for an empty set. Okay, this is a symbol for an empty set. What is a symbol for a subset? A subset is this, whereas a proper subset is that. Okay, 25. If 40 people speak Spanish, 25 speak French, and 10 speak both languages, how many speak one or both languages? Okay, this is Spanish. Here's French. 10 speak both languages. Okay, 40 speaks Spanish. So the number of people speak only Spanish is 30. 25 speak French, so 15 speak only French. So the number of people speak both languages would be 55. One or both languages is 55, and that's A. 55. Okay, I've got the choices written on this paper. I'm just going to not write them down. And number 26. Okay, if 100 people were surveyed about this problem, how many did not speak either of the two languages? So we know 55 people spoke one or the other, and there was 100 people surveyed. 100 minus 55 will leave you 45 that did not speak either language. Did not speak either language. And this is the last problem we're going to do. Okay, a student constructed a circle graph for his teacher. He spent 4 hours a day in academic classes, 1 hour in choir, 1 hour a day for lunch, and 3 hours on electives. How many degrees will be on the circle graph for the academics? Okay, there was 4 hours on academics, 1 day in choir, and 1 day for lunch, 3 hours on electives, 4 and 3, 7, 8. There's 9 hours altogether. And 4 of them were academics. So 4 nights multiplied by 360 gives me 160. So 160 degrees represents how many hours on academics. Okay, this is all of this video. Okay, I hope you enjoyed this video, and if anybody on YouTube who watches this, who give me a thumbs up if you don't care, or make comments on the video, how I could improve it, or what you liked about it, anything like that. And for any of my students in my classes, please, if you have any questions at all, please get in touch with me and let me know, or make comments on Blackboard. And if you have any questions whatsoever about anything, I'll give you a copy of my email address, which nobody's commented, sent me any email questions, but you can send me a email at my personal email address, okay, if you want to. And if you're one of my students in my classes, you can send me a question at my email address at work, okay? So anybody, I really hope you enjoyed this video. This has been a little long, but I really hope that you accomplished something by watching it. You can go back and watch it again if you want to. Okay, so everybody have a nice day, and good luck to you.